All right, so the last part of 5-6 is we talked about inverses. And to tell if something is an inverse of each other, you actually plug them into one another. And when you plug them in, they should simplify to x. So what it looks like is you're supposed to take f of the inverse of f of x. So what this says is you're supposed to take, remember, if I said f of x, right, or I said f at 2, this means you're going to take and replace whatever's in here, right here, for the x. So like if I had x plus 2, right, this would now read 2. Whatever's in here replaces only the x, and everything else stays the same. Well, that's the same here. This right here is going to replace x. Well, since it's x, it's just going to stay x. But this right here, the inverse function, is going to replace your x in the f function. So if they are truly inverse of each other, when you do this, this is going to equal x. And also when you do the inverse of f and you plug the original f function in, it will also simplify to x. You have to check both of these. Both of these have to check off. If they don't, then they're not inverses of each other. So, example real quick. If I said f of x equals 2x plus 5, if I asked you to find the inverse of that, the first step is to change the f of x to a y. This is review. The next step is to change the x and the y's positioning. Nothing else changes. Everything else stays the same. And then we solve for y. So we minus 5. X minus 5 equals 2y. We divide by 2. So my final answer would be y equals x minus 5 over 2. And if I did this correctly, then the f of inverse of f of x should all simplify to an x. That's what it should all simplify to. So basically, I'm taking this function and plugging it into this one as the x. So right here, I'm taking this and plugging it in for the x. And if I do that, it should simplify to x. So let's test that. 2, that's from right here. Time out, take this out, put all this in its place. So I'm going to put a x minus 5 over 2 right there in the place of the x, and then plus 5. Well, when I do that, this 2 is multiplying and this 2 is dividing, so these two cancel out, and I'm left with x minus 5 plus 5. And when I do that, the minus 5 and the plus 5 cancel out. Check. So the f of inverse of f of x does equal x. So test 1 is done. So I know that that worked. And now my final test is to do basically the same thing except reversed. So I'm going to do the inverse of f of x. So that means I'm going to take this whole function and plug it in for the x. So it's going to read 2x plus 5, that's this x, minus 5, all divided by 2. And when I look at this, these parentheses actually don't matter. I do always plug in with parentheses, but then I first decide, do they matter? Well, there's nothing here to distribute, so actually I can get rid of those parentheses. And the reason that is important is because then the plus 5 and minus 5 cancel out. 2x over 2, the 2's cancel out, and I'm left with just x. So since both of them simplified to an x, I know that I did this correctly, and this is the inverse of that. So your job is, I'm going to give you the two functions. This is your first function. This is possibly the inverse of that. I want you to tell me, is this the inverse of this, yes or no, and with proof? Yeah, Jonah, sorry. Today was the last day. I told you guys that had to all be turned in by today. Sorry, bud. All right, that should be enough time. Raise your hand if you think that these are inverses of each other. All right, raise your hand if you think that they are not inverses of each other. All right, those of you who said that, you are
Wait,
correct.
I changed my mind.
You say that it is an inverse?
Yes.
All right, Oris, what you should have done, right, is you should first take the inverse, which is this, and plug it into the x. If I do that, it turns into 1/4 4x minus 7 plus 7. And if I do order of operations correctly, I distribute this 1/4, which does turn this into x. But then it turns this into a minus 7/4 plus 7. And this right here, I really don't give two craps about what it is, but I know it's not 0. I know this is going to read x plus something. And since there's x plus something, it did not simplify to just x. So I know, no, these are not inverses. And I don't even have to do the other one. Now, if this one would have turned into x, you would then have to do the second one. You would have to take all of this and plug it in for here. And it would also have to simplify to just x. They both have to work. If one of them fails, then it's no longer an inverse. Does that make sense, Orist?
Yes.
Another one to try. Go ahead.
Would the leading coefficient have to be opposite sign?
No. No, this would have, if you change this to a, if you change this back here to a 4, then it would have worked.
Oh, okay.
No. If this would have been a 28, sorry. If that would have been a 28 back there, then that would have worked because at least it would have worked for the first one. We have to test to see if it was. So if that was a 28 instead of a 7, then this would read 1/4 times 4x minus 28 plus 7. And when I distribute this, this would turn into an x. This right here would turn into a minus 7, and then a minus 7 and a plus 7 would cancel out, leaving me with x. So boom, that would work. But then I have to take all of this and plug it in here. And so I would do 4 and then 1/4 x plus 7. And then this is minus 28. And distributing this, that would turn into just to x. This times this would turn into a plus 28. This would turn into a minus 28. And boom, I'm left with just x again. So if this was a 28 and minus 28 instead of a minus 7, it would have worked. Try it again real quick. Are these inverses of each other? Raise your hand if you think they are. Raise your hand if you think they aren't inverses of each other. Kelly, did you try this one?
Yeah, I'm not, I got like the first one, it went out to X, but I'm kind of like blanking on the second one, I don't know why.
All right, so for the first one, you're going to take all of this, plug it in for right here, right? So it's going to turn into the cube root of x cubed plus 1 minus 1, right? This looks exactly the same except for the x. This is the x, right? I just took all this and plugged it in its place. Do those parentheses matter? Nope. You notice I ask myself a lot of questions in math, right? That's a key. So do those parentheses matter? No, they don't, because there's nothing to distribute. And when I take them away, a plus 1 and a negative 1 cancel out. A cube and a cube root cancel out, leaving me with just x, like you said. So what happens here when I go to plug this into right here? Well, you're going to write everything the same. You're going to write cube root of x minus 1. That replaces the x. Then all of that is supposed to be to the third power. That's that part. And then plus 1. Well, what happens with a cube and a cube root? What do they still do to each other? They cancel out. Then I'm left with x minus 1 plus 1. A minus 1 and a plus 1 cancel out, leaving me with just x. So yes, they are inverses of each other because both times when I plug them into each other, they reduce to just x.
I just took out the cube on accident. I didn't put it back in.
Does that make sense now?
Mhm.
And that's the rest of 5-6.